one tweet. Back when I was on Twitter before evil things happened to it, now I'm on Mastodon, I saw a single tweet, and this guy said, I just figured out a new server-side template injection shell followed by 4 lines of impenetrable garbage that looked vaguely like SQL injection. And I said, what is server-side template injection? And so I spent like a week figuring it out, and it is bloody awesome stuff. So if you go to my vulnerable server, which is running on this port 6060, okay, you can search for users here. So if you search for like Sam, it will always tell you it found it because there's in fact no real database behind here, but it pretends there's a database and it finds whatever you give it. So user Sam exists, so that's not too exciting. But this turns out this is using modern web design, which you might have noticed from my web page, I don't know modern web design. My web page is just as good as when I wrote it in 1996. In fact, it's just the same as when I wrote it in 1996 because I wasn't interested in learning any of the modern frameworks. But in the modern world, you don't have a static HTML file. You have a template with fields that are filled in from databases and stuff, so you can fill in the ads and the products and the message of the day and all that stuff. And it's written in a so-called template language, which fills them in. And that's what this is. So if you go to this one, double apostrophe, let's see, I gotta go here, double curly braces. Let me make this bigger. All right, double curly braces, 1 plus 1, double curly braces. The double curly braces indicate a template field, and here they did not prevent me from adding templates in through the form, which is the same old flaw in command injection like all the others. Data that came from the user is misunderstood as data that came from the administrator. So now, it should, in the fullness of time, respond to. But there appears to be a delay or something in the response. I'm going to go ahead and hopefully it'll come up. So you can put in, if you search for that, it'll turn into 4. So it executes the mathematical stuff you put inside there. It doesn't just repeat it literally. So I'm able to execute commands on the server, but I'm executing it in this SSTI language, not in Bash or PHP or anything. So now you can fingerprint the server. This is a way to find out what server you have. You try these. If they work, you follow the green arrow. If they fail, you follow the red arrow. So the first one is single curly braces with $, 7 times 7. So let me stop this, and let's try that, 7 times 7, in single curly braces, and search for that. And it looks like I might have a serious networking problem preventing this from moving, but that's all right. I'm not going to worry about this one too much because I want to show you some stuff for which I don't need that. So the point is you can fingerprint this and eventually figure out which platform is being used for templates, and that's fun. But now let's talk about, you want a shell. All you've got is the ability to put a string on a web page. So how do you get a shell? And the answer is Python 3. Python 3 is amazingly dangerous and glorious and fun. So let's find out how to hack Python 3. This is a Python 3-based framework. So I just run Python 3 in immediate mode. This will do for what we're doing. So now I can make a string like hello. And as I mentioned before, in C, strings are just byte arrays. But in Python, they are character objects. They are, in fact, really complicated objects. You can do a directory of that object S to find out what it can do, and it can do all these things. It's a whole lot more than just 5 bytes. You can do all these things to it. So, for example, it has something called class, which is what type of object it is. So you can do s dot underscore underscore class underscore underscore, and that will tell you it is a class string. Okay, well that makes sense. It's an object of type string. Now you can also execute methods, like lower is in that list. That will, that's the name of the method which does it. That is not running the method. That is just a pointer to the operation that would do this. You have to put parentheses here, and now it will execute that and turn it into the lowercase. And there's upper. So this object has attributes and methods, and these are some of the methods attached to it. So now we can walk up the hierarchy. So we did s underscore class here, and we found out that was a string. Well, we can wonder what class is the class string. I can do dot class again. And the string, so the S is a string, and string is a type. And I can walk up again, but the next time I have to do base here. And now I get to object. I have walked up the hierarchy to the root of the entire Python structure, which is the object. Everything in Python is an object. And so now I've made it up the hierarchy to the top. And there's a reason. I've started here with a string, and I've walked up to the top. Now I can walk back down, and I can execute methods on an arbitrary object. So I can go to subclasses, and I can go to catch warnings, which is a method that actually contains an import method. So what I can do is when all the developer did was give me the ability to put in a string, I can import a Python library that the developer did not intend to import, which is pretty mind-boggling, just by putting it in a string. So that's what we're going to do. So we walked up the hierarchy to the top. Now we're going to enumerate subclasses. So I import OS, import subclasses, and then do S-class base subclasses. So let's do that. Didn't let me copy and paste from my browser because it's a little bit rude. I got to do it this way because I'm using Opera because it's prettier. All right, so here are all the subclasses of the subprocess method. And the point is, there's a long list of them, and I can count them here by putting them in a variable to see how many there are. There are 232 of them in this Python install. It varies on your Python version and such. And I can list all the function names. So here's the first 185 of them. There's a lot of them. All right, what I want is to find this one called catch warnings, because that's the one that has an import method. So I can hunt through the list and find the one that contains the word warning. And if I'm lucky, this will work. It didn't work, so I think I need to have all of them, which was, in my case, 232. So let me try that. 232. 3, 4. 1, 2, 3, 4. Okay, it's 209 in this Python install. That's the magic number that will get me to the catch warnings. So now I can enumerate the built-in methods. So I do x equals c sub 209. And then run this stuff, and I'll see the module. Did you guys see what I did wrong? Oh yeah, my catch warnings is fouled up. Thank you. Good. All right. There we go. And did it crash or something? Let's see. Produces another long blob of results, so I'm not going to worry about it. So now we're going to put the output in a variable called b, find its length, and find its class. All right. Let's see if this one works. Yep, 158 dictionary. Good. All right. Now I want to find import in there. So I hunt in there for the word import to find out which one it's in. And I better try and copy this all correctly. There we go. All right. I did not copy this again. I have a little trouble copying in my browser. There, that did it. All right. The function is import, underscore import. Okay, so now I can do code execution. I do the module, I go to the build-ins, I run import. Now I import the OS library, which gives me a system command to execute system commands, and then I execute the system command date. So now I have taken the ability to inject a template into a template engine, and I've turned it into arbitrary bash command line execution. And this, by the way, is the point of exploit development. You find some kind of flaw, and then you turn it into a more useful flaw. So you turn it from like a denial of service into an arbitrary code execution, and that's what we've done here. We turned it from something weak and boring into something fun and awesome. So there it is. It ran the command date in the operating system, and all the developer intended to do was harvest a string from me, like your username and password. But because they didn't understand that I could put in special characters and they would be misinterpreted by a Python-based template engine, I can take over the whole box and have a shell. And that's the joy of command injection. So anyway, there's a few flags defined here on these various cases.
If the input is escaped, is there any way to still do SQL?
This is the wonderful question. Yes, the cure for all this is escaping the input or filtering the input, and that just is a challenge to the hacker to find another character you forgot to block, and that you start a race. That's why.
But just flat, like, I know there's like, what do you call it, cleanse?
Yeah,
I forget the actual name of it, but it's like one method. I'm sure it's not an actual coverall.
No, URL encoding. So
yeah,
you can try all those, and in different engines they work. URL encoding it or escaping it will sometimes stop the special characters and be interpreted as special characters, and those will stop specific attacks, but attackers are incredibly inventive at finding ways to sneak it past, like Unicode and WRL encoding. And so it turns out that much more effective is to write code which does not ever make a line of code that's interpreted, including user data. That's the real way. You should use, you should never create a line that's going to be fed to an interpreter in another language that includes user data. That's the better way to do it. And SQL will do that with parameterized queries. If you can put a SQL, in PHP, you can make a parameterized query that doesn't take a name from the user and put it between apostrophes. What it does is it defines a data object, which is tied to a data object, and it says, is the data equal to this data object, which cannot be misunderstood as a code object at all. So anything that comes in from the user is just read as data, and it looks in there for the data, but under no circumstances does it have a line that it tries to match apostrophes in that includes data from the user. That can be done. And that's foolproof as far as anybody knows. If you do it that way, nobody can do SQL injection. And there may be similar things here, but like I was talking about yesterday, one place where you need it, where there absolutely is not anything like this, is large language models. You put a query in ChatGPT, and all the rules the administrator put there are above you, and they're not separated from the data you put in. So you have command injection. There is no known way to tell the ChatGPT that these are the rules from the administrator, you have to obey them, and the stuff that came from a user, you don't really have to obey that. We need that, but we don't currently have any way to do that, and that means all the large language models are subject to code injection, and we were playing with it a lot yesterday. And people are trying to build those defenses, but they're in their infancy. Anyway, let me stop this one. I think that's it for the command injection here.